Hello all and welcome to my YouTube channel. Welcome to the course on LangGraph where we are learning the LangGraph in depth. This is the sixth video in this series, and if you have missed the previous videos, I would highly recommend go ahead and check out that. The link is available in the description below. In the last session, we have already covered the human in the loop while executing the workflow. We have seen with the help of breakpoints how efficiently we can interrupt the workflow as and when required, and then we can seek a human approval before proceeding further so that human can validate whether the workflow is going in right direction or not, and after the human approval it moves further and completes the execution. And we have seen why it is important, and we have seen this with the help of a very simple shopping agent example, as you can see on the screen. And in the today's video we are going to continue the same example in order to leverage the edit or update state and the human feedback in the LangGraph workflows. Now, why exactly it is important to edit or update the graph states whenever we are executing the workflow? So what happens, sometimes user may change their request or user may want to update the previous message. And in those cases, it is very much important so that user have a feasibility to go ahead and update the previous message. Let's understand this with the help of ChatGPT. So currently on ChatGPT, let's say if user is asking a question, let's say, how's the weather today? Very simple question that I have asked. But now you can see that it has given me the weather conditions in Pune. But for example, let's say user may forget to update the city here. So in that case, how can I go ahead and update the previous message? In those cases, you can see there is one edit option available from where we can go ahead and update. Let's say, okay, how's the weather in Delhi today? Now in this case, what it will do is it will go ahead and regenerate the response, and now you can see it has generated the response for Delhi. In this case, what happens is it is generating the response, and after that you have the feasibility to update the previous message. What if you have the feasibility to interrupt the workflow in between, and in that interruptions itself you can go ahead and correct your previous message? That feasibility our LangGraph provides, meaning before going to the LLM and executing it, you can go ahead and update your message. That way you no need to waste your tokens. Let's say initially I waste my token, right, because it went ahead and generated the response by extracting the details weather conditions in Pune. But actually I was looking for Delhi. Because of my small mistake, I wasted some of the token. Now this is a very simple example that I'm talking about in general. But think of it as a larger picture. Let's say in organizations you are using, and wherever you have built an agentic framework, and there are chances that okay, if something goes wrong, it is going to generate a tremendous responses for you. So in those cases, there will be a loss of tokens as well. Also, user needs to wait for the current process to get complete. Let's say if it is generating 5 pages response, you'll have to wait for 5 pages to get complete, and after that you will have feasibility to go ahead and update your previous message. So in this case, let's see how exactly we can interrupt the message in between and then pass our corrected message. So that is what we are going to see in today's video. So let's understand this. Okay, so as I mentioned, approval we have seen in the previous video where we have interrupted our agent and then given the user acceptance. Now let's continue with the editing. So why it is important? Because as I mentioned, user may change their request midway. For example, a simple example I have given, price of 4 apples. That is the question that user put in initially, and later on user changed the mind and user want to know the price of 5 apples. So in that case, instead of hitting to the LLM before itself, user can go ahead and correct the input message. Now, also, editing state allows us to update the agent's understanding without restarting the entire workflow. We no need to go ahead and restart the entire workflow, because sometimes what happens, if you start the workflow and if you put your user input message, then your workflow will start and there is no opportunity for you to interrupt the workflow. In those cases, you need to restart your workflow, and to avoid that, you can use the editing or updating state. And again, it is essential for human in the feedback for debugging and correction options. So obviously, whenever you are testing the application, then this helps pretty much. Now let's understand where exactly it fits in. So breakpoint pauses the graph execution before the agent runs. This is a key point. Before agent runs, meaning you are saving your token. You are not even executing anything. Before itself, you are having an ability to interrupt the execution and update the state at the particular node, and that node we are going to define. We'll see that how exactly it happens. And at this point, we can inject the edit state before continuing the execution, and this gives us the fine control over what happens next. So that is how we can go ahead and control this. Let's see how exactly it operates behind the scene. So behind the scene, it uses the reducers and add message. So reducer is nothing but a function that controls how updates are applied to the graph state. So there are two ways of updating. First one is append, where we are going ahead and appending the user message into the previous message state. And second one is the overwrite. Now in the overwrite, it goes ahead and overrides the previous message. Now there are different use cases for these two, and let's understand them in depth. Now this, I am going to cover how exactly this add message function works. Let's see that practically. Okay, so this example we have already seen in the previous video, where we have installed the dependencies and we have used Azure OpenAI in order to enable the LLM capability for our project. And these details again we have covered in the previous sessions, how exactly you can grab those. So you need to deploy the large language model. So let me quickly show you that. In the deployment sections on Azure, we have deployed GPT-4o model. From here we have grabbed the we have grabbed the model information like the key and the endpoint. Those details we have added here. And then we have defined GPT-4o model and the model version. So let's go ahead and execute this. And this is the simple example that we have seen. We have added different tools like check price, add to cart, calculate total. So as you can see here, these are the tools that we have built: check price, calculate total, and add to cart. And based on these tools, we have bind those tools to our large language model. And then we have built this simple shopping agent where we have added a agent. And let me quickly show you that. So we have added a start age, then agent, and we have added a interruption method for agent, and then end state and the tools. So whenever user is inputting any question, agent is interrupting, and then you can take a call. So in the previous video, we have seen how we can add interrupt at both agent level as well as tools level. So let's go ahead and see. So, and this is how we have built the workflow, and this is how we have tested it. Like, let's say we are asking the question, what's the price of 2 chocolates? So it will go ahead and get us the price of 2 chocolates. So those details we have already mentioned here. You can see price of chocolate. So if price of 1 chocolate is 100, 2 is going to be 200. And then you can see as we have added an interrupt in between. So here we have passed input message, streaming mode we have added as values. So based on that, it will show us all the previous messages as well. And interrupt, you can see we have added before agent. So as it is before agent, you can see it has executed and stopped. This is the user question, it has stopped. Now, as it has stopped at this particular place, we need to ingest or update the message at this state, and then it should go ahead and call the further tools. But let's understand, before going further, let's understand how exactly the state is written. So with the help of get state, and if you are passing the thread, it will give us the state. So if we print that, you can see this is the message that we have passed. Then this is the ID, message ID. Please pay close attention to this ID because we are going to play with this particular ID now. And then this is the thread one and other information that we have added. But as it has interrupted, so you can see that it is still going to access the next step. So in order to access the next step, we know that we can go ahead and run this particular same command by just removing the input, initial input, and replacing it with none. But before that, let's see how what are the different messages. So same thing, you can see content is this that we have passed, and this is the ID that is available. You can see this is the content and this one is the ID. Now let's see how exactly we can go ahead and update this. So first of all, we are going to study the first method of appending. So in the previous message, we are going to append the new message. And in order to update the state, there is a simple function that is available called update state. We are going to use that. Okay, so let me add a simple code. You can see graph.update state. We are passing thread and the human message. So in this case, we have mentioned that, okay, what is the price of 2 chocolates? Then user wants to update. No, I don't want price of 2 chocolate. I want 5. In this case, user is not putting the complete message. User just mentioned no 5. As this is a append mode, it is going to append the new state in the previous message. That's where your agent knows that, okay, what previous message that the user entered and what is the context that the latest message that user have entered. So based on those two messages, the agent is smart enough to take a or generate a response. So in this case, let's append this, and as we have appended that, you can see on the same thread ID we have appended, you can see thread ID 1. So let's go ahead and check the state at this stage. So if I plot the state now, you will see two messages. Okay, you can see this was the previous message and this was the ID. And now we have added no 5 and you can see new ID has been generated. Oh, it has generated new ID because we are appending the message. Previous message is sitting at this particular address. As we are not doing the overwrite operation, it has created a new ID for us. That is fine now. We can go ahead and test the workflow now. Let's say for testing that you can use the same code and you need to continue the execution. So for continuing, you just need to pass none because input message you have already passed. This message is there in the memory. You just need to execute this. It will go ahead and update the message. You can see no 5 and then it has called the tool check price, and for that tool it has passed chocolate as an input and it has extracted 100. So 100 is price for one chocolate bar. Now for further, again you need to execute the same code in order to generate the further answer. Okay, you can see it has taken that 100 and you can see the final answer. The price of one chocolate bar is 100 rupees. That's where for 5 chocolate it would be 500. The initial input message was the what is the price for two chocolates, and now user has updated the message without executing the large language model or without hitting the call to the large language model. It has updated that message and now user got the answer for final question that the user have asked. So this is how this append method is helping us. And as you can see, it is very simple. We just need to add update state and we need to update our message. Now let's understand how exactly this happens in the override state. Now in the override state, we will be replacing the message at same ID. So in this particular message, we just need to go ahead and pass the message state as well. Okay, so let's go to the override now. And in the override, let me add the same thing. This is the input message. I'm starting the conversation on second thread so that we can test it. And then you can see event in graph.stream, we have added initial input, thread, stream value. So let's go ahead and print this. So now in the state, we have this first message, that is what is the price of two chocolate. So let me go ahead and copy the same thing. Let's test whether there is single message or not. Okay, indeed there is a single message at this particular ID. Okay, now let's go ahead and update the state. So for updating the state, this is a simple code again. Graph.update state, thread we have passed, message we have passed, but here you can see we have passed ID as well, and then the content. So this ID, message of 0 of ID. In the messages, this is the 0th message. What is the ID for that particular message? This is the ID. You can directly hardcode this ID at this particular place, but we have given it programmatically. For this particular ID, it will go ahead and override this particular value with this no 10, meaning user initially asked what is the price of two chocolate, but now user wants the price of 10 chocolate. In this case, if we go ahead and execute that, the model will fail. So if you see now, content, it is saying no 10 and additional argument, and you can see the ID is same to the previous one. Now, why the model will fail? Because now the previous state has overwritten. Whatever message that user passed previously is overwritten with no 10. Now model will confused what is no 10, what exactly the user is trying to achieve. That it will not be able to figure out. And let's execute this and we'll see. So again, we can use the simple code, but here we just need to pass none. And if we execute this, it will, okay, you can see it has asked the clarifying question that, okay, could you clarify what do you mean by number 10? Are we referring to an item, quantity, or something else? Meaning with updates, it is always you need to re-enter the complete message, because in overwrite, it goes ahead and overwrites the complete previous message from the previous state. And that's where if it's append, you can easily go ahead and add the short message or just the changes that you want in the previous message, and it will work the way we have did here. We just passed number 5 and it worked and it gave us the price as well. You can see. But whenever you are using overwrite method, then you need to pass the complete message. So let's test this now. So let me change the thread ID to 3. If user is asking question, what's the price of two chocolates? This is what we have passed at this particular ID. Then here we need to pass the complete question. What is the price of 10 chocolates? And in this case, it will go ahead and override the previous message. Okay, you can see, no, what's the price of 10 chocolates at the same ID that it was registered previously. And then if you go ahead and execute this, it will go ahead and give us you the price of 10 chocolates. So you can see no, what's the price of 10 chocolate is the latest message that it picked, and then it is checking price for one chocolate is 100. So if you execute this once again, it will go ahead and give you the price of 10 chocolates. Okay, you can see the price of one chocolate is 100, so the price of 10 chocolates is 1k. So that's how you can go ahead and play with the update state that is available in the LangGraph. And I would recommend go ahead and use the append mode. So there are advantages of using append mode is that we have seen that it remembers the previous state, but the disadvantages is that it keeps the stale messages also. Sometimes if your message is completely different than the previous one, so in those cases, it does not matter what was your previous message, and it is better to clear that message because unnecessarily you don't want to confuse your model by passing the previous message as well in the prompt. And in those cases, your overwrite method comes and play a vital role because it saves your token as well, and also it avoids the model confusion because you are not passing any stale records into the message. So it is always mandatory to maintain a trade-off between using the append versus overwrite mode, and that's where most of the folks started using hybrid approach, where they have added their custom, where we can add our custom functions. So if let's say, or you can add an LLM call to decide whether to keep the previous state or not. So that's how like you can go ahead and update the previous states as and when required. Okay, so let's go ahead and continue. Okay, so let's understand how exactly we can test this in the studio. So for studio, we have already seen in the previous video where we have created the 05 studio and where we have created these agents and LangGraph file. So in this session also, let's go ahead and create the studio to test our update state. Okay, so I have opened my Visual Studio Code, and you can see in the previous session we have seen this 05 studio. Now let's go ahead and create new folder. The code is exactly same. And what I'll go ahead and do is I'll copy these files, environment, LangGraph, requirements and agents into the same folder. Okay, because the code is exactly similar, we have these functions. So you can see in agent.py, we have same check price function, then add to cart, calculate total, and those functions we have registered as a tool for our agent. And then we have built this beautiful, simple agentic graph, which is going ahead and starting the conversation and compiling that. So this is what we have added. Now let's save this, and let me go ahead and add the environment details quickly. Okay, so I have updated my Azure OpenAI key and the OpenAI endpoint. So let's save this. LangGraph.json, again similar LangGraph.json, we are executing the LangGraph Studio on local. That's where we no need to pass any Docker file related information. This is the agent file path. Then this is the environment related path, and that's it. And in the dependencies, we have requirements. So in the requirements, we just have common requirements that are required for the LangGraph Studio to work. So let's save this. Let me open the new terminal and let's activate the environment. So we have activated environment as LangGraph. That's what we have created. And in order to run the LangGraph Studio, the command is very simple, LangGraph dev. Let's hit enter. Okay, it is saying this path is not exist because we are not in that folder. So let's go to 06 folder and then let's hit LangGraph dev. Okay, you can see now the LangGraph has started at this particular location, HTTP. So it is taking us to the Langsmith. On the Langsmith, we'll be able to see. Okay, you can see this is the workflow that we have created. We have start, agent, end, and tools. Same thing that we created here. So same code I have copy pasted. Start, agent, end, and tools. Just we have not passed any interruption. So if you can see in the compile, we have not mentioned any interrupt method. But in the Jupyter notebook, if you can see, we have mentioned interrupt before as agent. So that we have not mentioned because we have a feasibility to pass the interrupt at agent level. So you can see here, you can go ahead and add the interrupt, or you can disable that. So here, let's go ahead and enable this interrupt, and let's ask the user question. Sorry, let's ask the user question. Hi, what's the price of 10 apples? Simple question that we have asked. Let's submit this. Now it should go ahead and stop at agent level. You can see it stopped to agent level. On Studio, we have this feasibility. You can go ahead and edit the state, but how exactly you can go ahead and edit that? So you can see there is small edit node option available. So you can click on that, and instead of 10 apple, you can go ahead and make it 5, let's say. And then there is option to fork it. Fork will go ahead and update your message. So once you click on fork, you can see it passed through the agent and it went to the tools, and at the tools, then it has extracted the information that okay, it checked the price for apple is 30 per piece, and then again it came to the agent. As we have added interrupt at agent, we need to give approval, so we have given approval. It will go ahead and generate the final response now. Okay, the price of one apple is rupees 30, so the price of 5 apples would be rupees 150. So you can see instead of 10 apples, now it has generated the price for 5 apples. So this is how quickly you can go ahead and test it on the LangGraph Studio. Okay, let's go ahead and test one more example. But for that, let's go ahead and add the new thread. So on the new thread, we are let's pass the input. We are asking a simple question. Please add 2 apples and 10 chocolates to my store. And let's go ahead and hit submit. It should go ahead and wait for human input. You can see it is waiting for human approval, but you have the option. You can go ahead and edit, and you can go ahead and make it 5 apples. Click on fork, and it will continue the conversation, and again it will wait for human approval. You can see if you click on that, because it has extracted the detail, it is called the add tool, where it has added 5 apples. Also it has added 10 chocolates, and then you can see it is returning I have added 5 apples and 10 chocolates to your cart. So this is how, with the help of LangGraph Studio, you can go ahead and quickly test the workflow that you have built. Okay, coming back, there is another option that is available on LangGraph where you can consume the API where the LangGraph Studio is working. So let me go ahead and expand this. So okay, you can see you can simply pass the URL where your LangGraph is working. So let me show you that quickly. So if you see, our LangGraph is working at this particular address. So we can call this particular API by passing this particular address to our get client from LangGraph, and then we have created the client. And then here you can ask the question. Let's say, what's the total bill if I buy 5 apples, 3 milk packets, and 2 chocolates? And then this code we have already seen in the previous video. Like we are just starting the thread. We have the agent, and we have passed the initial input. Stream values is mode, and interrupt before is agent. We have added the interrupt before agent. So if you go ahead and execute this. Oh, sorry, client is not defined. Let me execute this. Then it will start the conversation. And as you can see, okay, what is the total bill if I add 5 apples, 3 milk packet, and 2 chocolates? And then you can go ahead and see the current state of the agent that we have. So you can see the message state is this, and you can see the message ID that it has generated. Now, if you want, you can go ahead and update this particular ID. And in order to update that, let's say, first of all, let's understand what is the last message. So from current state, we can extract the last message. -1 is for last message. You can see these are the details for last message with the ID. Now you can go ahead and overwrite this message. You can go ahead and overwrite, because you can see, let's say, content. Instead of this, we can pass this particular content. No, I want total bill if I buy 1 apple, 3 milk packet, and 2 chocolate. We are going to overwrite this particular message. So let's execute this. Now our last message is very simple, and you can see the state is same. If you see, the ID is same. At the same ID, we have overwritten the message, and that message now we are going to pass to the thread. You can see update thread, where we have passed thread ID and last message. So let's go ahead and execute this, and then let's go ahead and run the workflow again. So it should go ahead and change that. Okay, you can see, no, what is the total bill if I buy 1 apple, 3 milk packets, and 2 chocolates? And then it has generated the response. Okay, then it will go ahead and generate the response. But as we have added a human interruption at agent level, it has interrupted the workflow. So we need to execute this step again by passing none. So if you execute this, it will go one step ahead. And okay, you can see it has extracted the prices for all those details. So for apple, it has extracted the price. For milk, and then for the chocolate, it has extracted those details. And then again, if you execute this, because we have added interrupt at node level, that is where it is, or interrupt at agent level, that is where it is interrupting. So to continue, we can execute this once again, and it will give the final response. So you can see total bill is 410. If you buy 1 apple, 3 milk, and 2 chocolates, this is your total bill. That is your final answer that it has generated. So that's how it works. Now, with the help of API, we have used the LangGraph Studio. So if you want to test that, you can go to Langsmith, and in the thread sections, you can see the multiple threads that it has generated, and you can see all the conversation I have captured in this particular thread. The questions that we asked on the Jupyter notebook, you can see and leverage those details. You can test those details here, whether the interrupt happened properly, whether the message update happened or not. You can see what's the total bill if I buy 5 apples, and then you can see later on it has extracted the details and it has generated the final response for total bill for buying 1 apple, 3 milk and 2 packets, meaning it is showcasing all the information on the LangGraph Studio. So from where you can go ahead and track your experiment, how exactly it happened, and you can test the application. Okay, the last part, now we are going to go ahead and add the awaiting user input, meaning, so this is fine. You have added a workflow in which you have added the interruptions at the agent level, and then you are changing the message. But how exactly we can manage that on the go? So let's understand this. So just let me go ahead and just quickly change the workflow that we have created. All the details are same. Just we have added one more node, human feedback. Now, as we manually went ahead and updated or edited the workflow state, instead of that, we can add a one node which will take human input, human feedback, and you can update your message in that particular feedback itself in order to smoothen the workflow. Rest all the details are same. It's just in the interrupt before we have given human feedback as a node instead of agent. So let's go ahead and execute this. You can see the conversation will start at human feedback where we have added interrupt before, and then agent and then tools. Previously, we added the interrupt at agent level. If I show you that, you can see we have added the interrupt at agent level. We have just added one more node, human feedback, this particular one. Now let's go ahead and add the or start the conversation. So for example, let's say we are asking the question, what is the price of 2 milk packet? So in this case, this is the workflow. This is the way we are running the workflow, where we have passed user input message and the thread. So we are starting the conversation at new thread, and then you can see we have just given one user input. Tell me how you want to update the state. And then once the state is updated, you can see with the help of update state, we have updated the state, and then we are continuing the conversation. We have added a for loop until the conversation, or like whatever steps are that are pending after this post approval, it will go ahead and execute those. Earlier we used to manually execute this particular step, but now we have added for loop so that we can automate this particular workflow. So let's execute this. You can see what is the price of 2 milk, and then you have a update state. If you want to update, you can update that. Let's say, okay, no, what's the price of 5 milk packet? You have asked this particular question. So you can see it, as we have added the mode as stream mode as values, it will show the previous message as well. You can see what is the price of 2 milk packet was the previous question. Then we updated it to 3 message, and then it went ahead and checked the price. So the price is 60 rupees. So let's go ahead and run this again to get the final price. Okay, the price of 1 milk packet is 60. So the price of 3 milk packet would be 180. So this is how you can play with the update or edit state in the LangGraph, and you can, with the help of which, you have now more control in managing the graph. Now, so you might have heard that the LangGraph is the agentic AI framework which offers more customization, and this is the reason you can see the one we have seen now. You have more control over your agents. You can add a lot of customizations as compared to the other frameworks that are available out there in market like AutoGen or Crew AI. So yeah, definitely. Whenever you are working on building the agentic AI framework with the help of LangGraph, it is always a bit complicated because you need to manage the graph. You need to manage the workflow with the help of graph. That's where it is a bit critical. But as it has a graph structure, it gives us more feasibility so that we can go ahead and update the workflow as and when required, as well as we can build our customized workflows. So yeah, I hope this edit state and human feedback in the workflow, in the LangGraph workflow is clear to you. And if you have any questions, please feel free to drop them into the comment sections and I'll be happy to answer those. So yeah, I hope this was helpful for you. So I'll see you soon in the next interesting video in this particular series. Till then, thank you so much and I'll see you soon in the next video. Thank you.